Yes, Varun. Good evening. Are you ready? Okay. Don't come very closer to the monitor. You're scaring me. Yeah, that's the correct position. A little bit away from that, okay? You know that there is a term in physics when you are specifically talking about ray optics, right? There is a term called least distance of distinct vision. Least distance of distinct vision. Do you know that? No. The minimum distance with which you have to keep away from the book so that you can read the things legibly. Distinctly you can see objects. That is called the least distance of distinct vision. For example, when you are reading a book, it must be around 25 to 30 centimeters. It should not be very closer. If it is very closer or if it is very far away, your eyes will get strained so that your specs power will keep on increasing. Already you are wearing a specs, like me. So it's better to keep away from that so that you can protect your eyes properly. Okay? Right. Now, let us go to the next part. So far we have seen about the what are the advantages and disadvantages of series connection and parallel connection, isn't it? Now the next problem, how can three resistors of resistances 2 ohms, 3 ohms and 6 ohms be connected to give a total resistance of 4 ohms and 1 ohm? In this problem, you can see that how we can connect these three resistors, whether it is parallel or series, right? So how can you calculate it with, we have got three resistors. Since three resistors are there, you can put it in different combination. That means first two resistors can be parallel or first and last can be parallel, one can be series. Like that you have to put the combination, then only we can arrive to the conclusion. Before that, only one point we can decide on that. Second part is very easy. Can you tell me why? The part B and all parallel. Why? Because? Yes, that is why. So, on seeing that, we can judge that for the second answer, all the three should be connected in parallel. But for the first one, 4 ohms, if you connect all those things in series, you will get 3 plus 2, 5 plus 6, 11 only. Isn't it? So, we have to put the, how can you judge that? How will you decide? For that you have to work out, isn't it? That you don't know. That's what I am telling you. No, that's what. It should be like trial and error only. How? Because, see, we will try that. What are the three resistances given here? Look at that. 2, 3, 6. Yes. So, as you said, we have to go for trial and error. 2, 3, 6, take that. 2 ohms, 3 ohms and 6 ohms. So, what is the trial and error method? First, we will take these two first as series. So, we will take the first option, 2 plus 3 first. That means it is 5. So, 5 is in series with 6. Now, we will try that. That is 1 by Rp is equal to 1 by 5 plus 1 by 6. So, 30, here it is 6 plus 5, that is 11 by 30, or Rp is equal to 30 by 11, which is not correct. Wrong. So, we will take next 3 and 6. So, 3 and 6 means these two should be 3 plus 6, 9. So, this 9 is in parallel with 2. So, 1 by Rp is equal to 1 by 2 plus 1 by 9. Isn't it? Now, try that. 18. 9 plus 2. 11 by 18. Or Rp is 18 by 11. Now is it right now? This option is also not correct. Then which one shall we try then? Now you try these two. 2 plus 6 series. That means 8 ohms. And that should be in parallel. So 1 by 8 plus 1 by 3. So 24. That is also not coming. So instead of 2 series on 1 parallel, now what we'll do? We'll take 2 parallel and 1 series. So all these 3 options are not possible. See, this is what, as you said, trial and error, because certain things we cannot decide on seeing that for the first time. So first you take these 2 first. So what shall we do? 1 by 2 plus 1 by 3. That means 6, 3 plus 2. That is 5 by 6, or RP is 6 by 5. So that is also not possible. So that is also not coming. So we will take these 2. So 1 by 3 plus 1 by 6. That means 2 plus 1. 3 by 6. That is 1 by 2, or RP is 2. So for this 2 and add these 2, what will you get? 4. You are getting the answer, isn't it? So that is the correct option then. Which one? This is the correct option. That means this 3 ohms and 6 ohms should be in parallel first. That means the connection should be like this. This 6 ohm and 3 ohm. And this should be in series with the third resistor. So this combination will give you how much? 2 ohms. And this one is 2. So 2 plus 2 it will become 4. So this way certain problems can be attempted only by using trial and error method. As these resistance are very small, so that you can easily calculate. Now tell me, what is the first procedure we have to do? Varun, tell me. Yeah, the solution. How will you arrive to the solution? We have got trial and error, we have got the... So, how will you write it in sentence? So this is how we have to do. First connect the 2 resistors, 3 ohms and 6 ohms in parallel to get a total resistance of 2 ohms. That means 1 by 3 plus 1 by 6 will become 1 by 2, so that RP will be equal to 2 ohms. Now, this RP, what you have taken is in series with the combination with the 2 ohms. So that the total resistance of the 3 resistors, 2 ohms, 3 ohms and 6 ohms is equal to this RP plus this second one, that is the previous one, 2 ohms will become 4 ohms. So this is how we have to put it in proper sentences. Actually, when you are doing this, it is better to draw the diagram. It will be easy for you. Even in the exams also, when you are going for higher classes, you will have to draw the diagram. As we have discussed already, the 3 resistors should be connected like this. First, the 2 resistors are connected in parallel. So what is the first one? It is 3 ohms. The second one is 6 ohms. Then we will say that RP is 2 ohms, isn't it? So now the second diagram, it will become like this. This is RP and this one is 2 ohms. So the circuit reduces to RP and 2 ohms. That is the previous one also you can add like this. This is 2 ohms. Okay. So this only we have shown it as RP and this one is remaining as it is. You may think that it is like a box, but here it is, if you connect that, it will be like this. It will be a series combination. Okay. So this is the method of reducing the given circuit into simplified form. In the future classes, when you go to 12th standard, you will be given with a resistor with a multiple bridges, that is multiple network. How the network has to be reduced in different way. Certain resistor in parallel combination, certain resistors in series combination. So that you have to understand how it is connected, then only you can get the result properly. Effective resistance of the given network can be found out. Okay, so if you make it thorough now itself, when you go to 12th standard, it will become very easier for you. Right, now next question. See, 1 ohm, that is what we have already discussed. The value 1 ohm is the least value, isn't it? Less than the smallest, that is smallest of the individual resistor, less than the smallest, because 2, 3, 6 are the resistors and the given resistor is 1 value, 1 ohm. So this is less than the smallest one, 2. So naturally all the 3 should be connected in parallel combination. So that we will get the effective resistance as 1 ohm. Okay. Now the next question, what is the highest, the lowest total resistance that can be secured by combinations of 4 coils of resistance 4, 8, 12 and 24 ohms? Of course, the second one is, that is the lowest is possible, very easy, because we know that if it is connected in parallel combination, you will get the lowest value. And similarly, what could be the highest? Naturally, when they are connected in series combination, you will get the highest value. Yeah, series and a parallel connection. So these are the 2 options, isn't it? So 4 plus 8 plus 12 plus 24, 48 ohms. That is the highest value. Similarly, the lowest value can be when they are connected in parallel combination, so that you will get 2 ohms as the lowest of the least one. Lower than the least one. Least one is 4 here, so that you will get less than that, which is nothing but 2 ohms. This is how we can get the value, whether it is highest or lowest, and in what way we can combine them so that we can get the desired value. We can do that. Okay, so very simple only. The next one is the another topic, which is a practical oriented topic, heating effect of electric current. Usually we know that whenever there is a current flowing in a conductor, which is providing that current, actually it is nothing but the battery. Battery is the source, or cell is the source of this electric current or electric energy. And even inside the battery also, whether we are using the torchlight battery or car battery, whatever it may be, inside that the chemicals are there inside. We call these chemicals as electrolyte. Remember that word. Here we are not using it. When you go to higher classes, you use that. The chemicals present inside the battery or cell is called the electrolyte. Now the reaction between the electrolyte, they only will generate electrons. Right? They will release the electron. One electrolyte will release the electron. Another electrolyte will absorb the electrons. The electrodes are there inside. Positive terminal, negative terminals are there. No, so they are called electrodes, through which the electrons are moving. Right? They are electrodes. So when the electrolyte is creating the chemical reaction between them, the electrons will start moving or away from there or towards the electrodes. And these electrons with the energy, they will be moving out of the battery through the external circuit, right? Whether they are resistors or capacitors or anything, through that they will be flowing out, right? So these electrons, right? These electrons can be moving. It is because of the potential difference between the terminals. How the potential is developed? Because if more and more electrons are accumulating, one terminal will become negatively charged, one terminal will become positively charged, so that positively charged terminal will attract the electron, so that the electron will flow outside the battery, that is in the external circuit, thereby maintaining the electrons. That is how the current is constituted. Okay. Now, to maintain this steady current, the source has to keep on expending the energy, keep on spending the energy. And when it is keep on spending the energy, that is the chemical energy is converted into electric energy. And this electric energy is keep on spending, that is energy is keep on spent everywhere. And where is it going? Because the electrons, after moving through the different components or different appliances what we are using in the electric circuit, the electrons, the current is flowing through that, again they are coming to the terminal. The electrons are coming to the next terminal. That means they are losing the energy. After all, we have to understand that what we are paying for the electricity board is not for the electron they are supplying. It's only for the energy that the electrons are carrying. They make the electrons energized and they are pushing that through the wire, and those electrons are transferring the energy to the electrons which we have got in our house, so that in the metal or the wire or the tungsten, these electrons carry out the energy, they lose that, and then for that energy only we are paying for the electricity board. Now, once we get the energy, where is it going? It is nothing but some part of the energy, the source energy, is maintaining the current which is used in a useful work. That is like if it is a motor, it is running. If it is a grinder, the grinder is rotating. If it is a fan, the blades are rotating. If it is a bulb, the bulb is glowing. So in all these ways, it is called useful work. So some part of the energy is utilized. Now, the rest of the source is expended or wasted in terms of heat energy to raise the temperature of the gadget. You know that if the fan is running for a long time, you know that it will get heated up, isn't it? Even the grinder or mixie, if it is running for a long time, it will get heated up, isn't it? That heat which is generated is nothing but undesirable one, which is nothing but waste of energy. So whatever the battery is supplying the energy, only some part is useful, utilized, and remaining part is wasted in terms of heat energy, right? Now, this is nothing but called a heating effect of electric current. How this part of the energy is dissipated, wasted entirely in a form of heat. Suppose if the circuit has got only the resistors, right? Oh. What do you say? Volume kammiya irundhathu. Do you speak in English or Tamil in your house? Tamil only. What's your mom? Okay. Okay, right. So, this amount of part of the energy which is dissipated in terms of heat energy, you know, this is nothing but called a heating effect of electric current, right? So, this heating effect is also, this concept of heating effect of electric current is also utilized in many devices like electric heater, electric iron, all the electric heating devices, right? Now, let us see how to get the expression for the heat generator in a resistor or in any conductor. Usually, it need not be resistor alone. Whatever be the conductor, if the current is flowing through that, definitely it will generate some amount of heat. If the wire which we are using in your domestic purpose, and that is not heated that much because the wire is having very negligible resistance, because it is a conductor, it is providing minimum amount of resistance, so that the current is flowing, little amount of heat only is generated in terms of heat, so that the wire is not getting heated up to that extent. But if the circuit has got more amount of resistors, or if the wire which we are using is not a good conductor, definitely the wire will get burnt out, so that more amount of heat is generated. Now let us consider a current I is flowing through a resistor. The resistance is considered as R. Now let us take the potential difference across that resistor be V. Okay, so the potential difference across the resistor is V, the resistance is R, the current I is flowing through that. Okay, now let us take a particular time duration, say t seconds. In t seconds, Q amount of charges are flowing through that. Q amount of charges flowing through the resistor, right? Now let us calculate the work done, electric work done. That means this amount of charge, Q amount of charge, has to be moved across the resistor from one end to the other end, across the through the potential difference, because the potential difference is providing a potential difference V. So against this charges has to be moved. So what is the value? It is nothing but V into Q, potential difference into Q. Okay, so that is the work done, electric work done. Now, suppose if the source must supply this amount of energy equal to VQ in time t, right? That is the battery, whatever the battery or cell is only supplying this amount of energy for the charges, right? Now we will calculate what is the power. Power is nothing but, we know that rate of doing work, isn't it? Power is nothing but rate of doing work. So we have taken the time t and we have calculated the work done. So work done by time is nothing but power. That is VQ by T. VQ by T. Power is nothing but work done by time. So in this work done is nothing but V into Q and time is nothing but T. Now we are separating this Q by T separately. So when you take this Q by T, this Q by T is nothing but rate of flow of charges. It is nothing but current. So instead of saying V into Q by T, we can say P is equal to VI. Power is equal to potential difference into current, right? Or the energy supplied to the circuit by the source in time t. What will happen for a particular time? How much energy is supplied? That means you will multiply this with the t, so that this is nothing but VIT. So energy supplied is nothing but VIT. Okay, in time t. So these are the two formulae you have to remember. Power is equal to V into I. The energy supplied. This energy is only what we say is generated as heat if it is purely resistive. So heat energy is nothing but we will say VIT, that energy. Now what happens to this energy which is expended by the source? That is what we said. If the circuit has got only resistor, it will be converted into heat energy. It will be converted into heat energy. Now we are going to calculate, or we are going to formulate the formula how to calculate the heat energy. So we say that the energy is nothing but, which is supplied by the battery is nothing but is converted into heat energy. So H is equal to nothing but VIT. So we just apply the formula by using Ohm's law. V is equal to IR. If you substitute that, V is equal to IR. Here one more I is there. So I square R into T. So this is the exact formula we are going to use. H is equal to I square RT, which is nothing but called Joule's law of heating. There may be a question, 3-mark question. State Joule's law of heating. So for which you have to remember this formula. By remembering this formula, you can give the statement easily. How can you give the statement? By keeping resistor as constant, and for a particular time, we can say that H is directly proportional to I square. Or if we say for a steady current, right, if resistance can be varied for a particular time, H is proportional to R, or R increases, H increases, right? Understand? So thereby we can state the Joule's law of heating, that heat produced in a resistor, H, heat produced in a resistor is directly proportional to the square of the current for a given resistor. And the second point, directly proportional to the resistance for a given current. And finally, third point, directly proportional to the time of passage of current through the resistor. Okay, time of passage of current through the resistor. So this is what the Joule's law of heating states. So if they ask state the Joule's law of heating, means you have to say H is equal to I square, to write the expression. Then we can say the Joule's law of heating implies that, states that, you can say implies means it nothing but state that heat produced in a conductor or a resistor, you can say. You can write the 3 points. Okay, each point is carrying mark, so remember that. This same question will be revising in 12th standard also, okay, in detail. Now, in this is how generally when you say that I is H is equal to I square RT, for what? What for? Yes, what did it ask? You studied. No, you studied, but in 12th standard also you will be studying this. Because these are all basic concepts, no? Again and again they will be utilizing this. Okay. So, if you know, in a circuit, if you know the resistor, value of resistance, and how much current is flowing through that, and what is the time duration through which the current is flowing through that, easily you can calculate the value of H. For which, if battery is provided, we have to calculate first current by voltage, potential difference, resistance values you know. By using V and R, you have to first calculate I, then substitute the value and calculate the value of heat generated in this circuit. Okay. Here there is a question here. You can see that an electric iron box consumes energy at a rate of 840 watts. There are two limits they have given. Heating at maximum rate and heating at a minimum rate. When it is at high rate, maximum rate, you know that in the iron box regulator is there, isn't it? So if you turn the regulator to the maximum position, we say that it is consuming 840 watts of energy. And when it is at the lowest position, it is consuming 360 watts of energy. And the voltage is, as we are using in the domestic purpose, it is only 220 volt. Now what is the question here? What are the currents and the resistance in each case? What are the currents and the resistance in each case? So what will you use? Which formula will you use? Can you guess? Yes? What formula will you use? That's all. Power is given. P is equal to V into I, and V is given. P value is given. Isn't it? So what can you find out straight away? You can find out the current. I is equal to V by P. That's all. So power P is equal to VI, I is equal to P by V. Substitute that value. I is equal to 840 by 220. So if you calculate, you will get 3.82. Okay. Are you very much thorough with the usage of logarithmic book? Yeah? Because this calculation can you perform very easy? Don't know. Why? Why do you say you don't know? Are they not teaching you to use a log book? Why? At 10th standard level, you are supposed to learn that. No, you have to learn. I'll teach you. I will take one class on that, so that. No. So generally, then how will you calculate these things? You will keep on multiplying, dividing, isn't it? Usually, even in matriculation, that is for matriculation schools, we suggest. Of course, earlier it was tough syllabus. Now I don't know whether they are using it. Of course, we can keep on dividing, but in the meantime, we will learn it, because though you are in 10th standard, it's very easy for you to learn also. In the future class, when you go to 11th and 12th, it will be of very use, because if you take 11th standard, in the very beginning itself, they will teach this usage of log book. Okay. Right, this simple division multiplication you can perform, doesn't matter. Now, the same formula only we are using for maximum and a minimum rate. 840 by 220, here 360 by 220, so that we are getting the different currents. Now we can notice one thing. By these two ways, what do you understand? By these two answers, what do you understand? Exactly. When heating is minimum, or when current is minimum, the heat generator is also minimum. When current is more, the heat is also more. That is what we understand. Okay. So next we know that how to calculate the resistance. Resistance is nothing but R is equal to V by I, 220 by 1.64, nothing but 134.15. Here, for calculating the current, in each case they are asking, what are the current and the resistance in each case? So that means, what we have to do? In both the cases we have to calculate, isn't it? For this current and voltage, for this current and voltage. Yeah. So that is V by I, that is 134.15. So the next question is, 100 joules heat is produced each second in a 4 ohm resistor. Find out the potential difference. So straight away when you are talking about heat, you have to remember this formula. When there is an electric circuit, when they are talking about heat, straight away you can remember I square RT is the formula we are going to use. So resistance is given, and the potential difference across the resistor is to be found out, and the heat energy, value of heat energy is given. So H is given, H is 100 joules, resistor is given, and each second they are given. So since each second we say T is equal to 1 second. So what is V? So formula, use the formula H is equal to I square RT. If you want I only, so you take the square root, H by RT, square root of H by RT. So H is 100, R is 4 into 1, so 100 by 4 is nothing but 25, square root of 25 is 5 ampere. So 5 ampere is the current, isn't it? So we have found out the current and we know the resistor. So we can straight away find out V. So V is nothing but IR. So 5 into 4, 20 volt is the potential difference across the resistor. Why? Here it is 5. Here 5 into 4, root square root, no, 25 square root. Square root of 100 by 4 it is 25, square root of 25 it is 5. So 5 into 4 is 20 volts. Okay. And the next one is another observation oriented question. Why does the cord of an electric heater not glow while the heating element does? What do you mean by cord? You know what is the meaning of cord? C-O-R-D. Cord is nothing but the wire. The power cord we say. For computer system and all we are using a cord, no wire. That power cord is nothing but cord, wire. So that wire of the heater is not glowing when the current is flowing through that. The same current only is flowing through the heater. For example, iron box or heater. The heater or iron box is getting heated, but the wire through which the current is flowing is not glowing. That is why they are asking. If it is glowing means everything should glow. It should produce heat. Why is it not? Why is it not glowing? They are asking. Okay, very simple question only. We know that the wire, the electric wire which we are using for connecting the different appliances is purely made up of copper. Copper or either copper or aluminum, which is a very good conductor. That means it has got very low resistance. So that when it is having very low resistance, the heat generated will be very, very less, negligible heat when passing through this, isn't it? So that it will not glow. So glowing is possible. When can you say glowing is possible? Only when the metal is becoming red hot, isn't it? Red hot, like your carbon or gas stove, when it is burning, you can see that it will become red hot. Then only it will go. Otherwise it will not glow, isn't it? So here the heat produced in that wire is not that sufficient to make that cord red hot so that it is not glowing. It does not glow. But the heating element, the inside the bulb, the heating element, the filament, or in the iron box, in the resistor inside the iron box, right? Have you ever seen the resistor in iron box, how it will be? Have you ever seen that in an iron box, iron press? The heat is produced, you know, how it will be looking like? Have you ever seen? No. Yeah, it will be like this, you can see. This is made up of a hard plastic. Inside these two, this plastic is nothing but non-conductor, isn't it? It will only transfer the heat, but it will not conduct electricity. So this inside this this filament will be kept so that it will not make contact with the handle or anything. So the heat generated, the current will be passed through this connection will be there here, so that it will start becoming red hot when the current is passing through that. So due to that, the heat energy will be transferred to the bottom plate, that will also get heated up. So that is how the resistor inside the iron box will be. Okay. If time permits, or if your daddy permits, you can just break the iron box and see. Okay. Or if you want to save money, you can go to shop and ask for a resistor, that is a filament for iron box. They will give you, it may hardly cost 40 rupees or 50 rupees only. You can just buy that and see how it is. But don't connect it when it is outside, because when you are connecting that outside the iron box, the filament after getting heated up, it will be coming out, right? It will be burnt. You cannot use it because it will become red hot outside. Since it is kept under compression, so that the heat is transferred to the bottom plate, it is used there. So the heating element is made up of an alloy in the iron box, which has got very high resistance. So you know that when the high resistance is there, when the current is flowing through that, right, it is something like in the Tamil film model you would have seen, when villain and hero are fighting, both are like opposite. Hero is positive and the villain is negative. When he is pushing, you know that their hands will generate a fire, isn't it? Fire will come out, or even the shoe will be making fire, or Vadivel also you would have seen in some film, when he is walking, it will generate fire, isn't it? So that way, this alloy, since it has got very high resistance, when the electrons are carrying the energy, it is not allowing to move very easily like villain. So it is opposing. So that energy is given out in the form of heat energy, so that more amount of heat is generated in the coil and it becomes red hot. So it is glowing. Otherwise it will not glow. Right? That is the answer for that. Now, we are asking you to compute the heat energy generated while transferring this much of Coulomb charge in 1 hour through a potential difference of 50 volts. So, we are asked to find out heat generated. What is that? H is equal to I square RT, we have to find out. In that I square RT, what do we have? We have got only coulombs of charge. Charge is given and V is given. V is 50 volts. So, Coulomb is given. So, how to find out current from this? Can you tell me? Using this, how will you find out current? Because we know I square RT, I we need. Once you find out I, by using V, we can find out R also. Time is given. Then how will you find out I? That's all. Q by T. Using that, I is equal Q by T. But time T here is given as 1 hour. So 1 hour is nothing but 3600 second. Always it should be mentioned in terms of second only. So 96,000 divided by 3600. So you will get 26.67 ampere. And from this current we can find out resistance V by I, 50 by 26.67, which is nothing but 1.87. Right. So by using these two data, we can find out H, I square RT. I square R into time is again in terms of seconds, 60 into 60. So by using this, we can get the value as 4.788397 joules. Such a big answer. If you keep on multiplying the exam, you will lose almost 15 minutes, isn't it? But it is always better to choose problems, because problems will give you full mark, and it shows your ability to analyze. Those who are weak in analyzing or weak in understanding the concept, they will never touch the problems. If you are brave enough to attempt the problem, that means you are able to understand the concept and apply that. So it's always try to solve as many as problems, because in the future classes also, when you are going for a competitive exams, entrance exam, all those exams, more importance is given for numerical problem solving. So from now on, start practicing more problem. Don't leave any problem from a textbook, or wherever you see. If you see any new book, there is a problem, means you try to attempt that, try to solve that. So that way you have to develop that ability. Okay. So by this way, you can just write it in scientific notation. This is called the scientific notation. By using this 4 point, we have to put the point here. So 1, 2, 3, 4, 5, 6. So 10 power 6. And again, this can also be simplified because this 9 is above 5. So we can add 1 with this. So it will become 4.8 into 10 power 6 joules. Now can you tell me how many units is that? 1 unit is equal to how much? Do you know? Remember that? Of course, it is not thought, isn't it? You don't know what is 1 unit. Yes or no? That we'll learn. Do you know that? In our houses and all, we are using how many units we have consumed energy from the electricity department. For that we are paying 1 kilowatt hour. Yes, that value in terms of joules we have to understand. Okay, we will calculate. Then we'll come to know it. The next one. An electric iron of resistance 20 ohms takes a current of 5 amps. Calculate the heat developed. Again, same question, I square RT. So I square RT, 5 into 5 into 20 into 30, which is nothing but 15,000 joules. Yeah, what is that? What did you say? What did you say? Joules. Yeah, that's what. Good. Now in this chapter we'll learn those things. Okay, practical applications of this heating effect of electric current. How we are going to apply this in the practical setup. As we have already discussed, though the energy supplied by the battery or cell is utilized, only part of this is utilized as constructive, and the part of the energy is destructive. That means it is wasted. But it is inevitable. We cannot avoid that. Unavoidable consequence of electric current. Right? And it is undesirable because it is converting the useful electric energy into unwanted heat energy. But not in all cases. But in the electric bulb, of course, we need heat. We need light only, but we don't want heat. But the electric bulb is producing both. We cannot avoid that. But in iron box, we need only heat energy. Isn't it? So, sometimes it is desirable, sometimes it becomes undesirable. So, in electric circuits, this unavoidable heating can increase the temperature of the components and alter their properties. Sometimes you know that even in the transformers, in summer season what happens, suddenly the transformer will get bursted because of the huge amount of heat generated in the it is only to a desirable value, no? Suppose if you increase that value to a maximum level, what will happen? Like Kavalan film you would have seen in Vijay Kavalan film, how he is using the pan to iron that. You will find 2 holes, you know. You will be asking, 2 holes are there, only 1 iron box is there, where is the other iron box, you will ask, you know. Like that will be. If it is beyond the limit. Because we are using that only within the range, so that we can iron that, isn't it? So in that way, if it is undesirable means what will happen? They will alter the property of the material which we are using. That means it will get melted up, it will get cut, so that it will produce in short circuit. So these are all called undesirable. But in spite of that, the heating effect of electric currents has got many applications. As we have seen, the laundry iron, electric toaster, electric oven, and then electric kettle, or the electric heater, all these devices, they are all based on the Joule's law of heating, right? The desirable, undesirable effect is made use so that it becomes desirable, right? So if that Joule's law of heating is not found out, we cannot enjoy all these things nowadays. In winter season, we cannot use this heater. We cannot make your dresses very neat by using this iron box. It's all because of the discovery, great discovery by Joule. So that we are converting the destructive into constructive, right? Now, similarly, as we have already discussed, the electric heating is also used to produce light in an electric bulb, right? Here, there is a filament, what we call it as tungsten filament, and this tungsten filament, it must retain as much of heat generated as possible, so that it gets very red hot, very hot, so that it can emit light. So the filament can emit light only when it becomes red hot, right? For that only they have to choose that filament in such a way that it will retain the heat. So related to that, you might have heard about the story when Thomas Alva Edison was trying to discover the bulb, right? In the lab, he was sitting round the clock to use this filament, suitable filament, so that the bulb will start glowing. So he used many number of times, he used different elements. Every time when he switches on the current, the bulb gets fused. He cannot get the light. But after a long research, 1 week or more than a week, they were doing the research in the lab. And finally, they tried this filament, tungsten filament, and suddenly it started becoming red hot and giving the light in the room. And by looking at the bulb, which is glowing, they were sitting hours together without taking food. They were very much happy. And after that invention, he was interviewed by the different press persons, and one first person was asking the question, Mr. Edison, you were able to fail for thousands of times. Were you not disappointed? He said. Do you know what is the answer he gave? It will be very inspiring. He said, of course I failed 1,000 times, but I don't think it as a failure, because I understood that all these 1,000 elements were not suitable. That is also a practical application for me. I found the 1,000th one element, so that only will be suitable. So that way, he has taken even the failure also in terms of success. That inspiration only made him invent nearly 1,026 inventions. He is the person with a lot more inventions, so that we are all enjoying because of his hard work, right? So in that bulb, the filament, filament has to retain so much of heat, so that, pardon? What is that? So many, I said no, thousands of inventions. You can just go on browsing and start listing how many inventions he has got. Such a great scientist. Okay, you can start collecting from today onwards. What are the inventions discovered by, or what are the inventions made by Thomas Alva Edison? Start making a list and then tell me. I will also share with you. Okay. Right. Here, as we said, this tungsten filament, it should not melt at high temperature, because it is retaining a very high temperature, high heat. So at that high temperature, it should not melt. So a strong metal with this high melting point should be used for making the filament in the bulb. So finally they understood that the tungsten is the best filament. Even right today also we are using the same filament only in all the bulbs which we are using. Right? So this tungsten filament has got the melting point. This value you have to note down. Sometimes they may be asking the question. 3380 degrees centigrade. It is the melting point of tungsten which is used in the bulbs. And here, this if you look at the structure, this is not the ordinary LED bulb or ordinary tube light which we are using. This is talking about a bulb which we call it as organ bulb. Organ bulb. Gundu bulb, that is called organ bulb, yellow bulb. And here the filament should be thermally insulated, so that with the insulating support, you know that in the bulb there is a support, insulating support. And the chemically inactive gas is present inside. Usually they use either argon or nitrogen. Usually they use argon, because argon is a inert gas which will not readily react. Okay, so when it is not readily reacting with the filament inside, so that it will be keeping the pressure and everything same, right? So that is why we are able to get the light continuously. Okay, so to prolong this life of the filament, that is an important point. They may be asking multiple choice question. Why is this tungsten used in the bulb, organ bulb? It is only to prolong, to extend the life of filament. If other gases are used, what will happen? They will react with the filament, thereby changing the filament into some other material, and they cannot retain the heat for a long time. They will get fused. So that is why they are using the inert gas. Okay. Here, most of the power consumed by this filament appears as heat, but as a small part of it only is radiated in the form of light energy. So in the bulb, that is why in the yellow bulb, if you touch, it will be very, very hot when it is glowing. But the ordinary, this LED or a CFL bulb and all will not be that much heat, because they are carrying different gases like mercury, right, neon, all those gases. But here, in this one, in the tungsten filament, since it is becoming very red hot, it is generating more amount of heat also. In that, most of the amount of energy is generated in terms of heat, only a part is radiated as light. That is why when you compare with the ordinary bulb and this organ bulb, the light will be not that much bright. Another application is, already we discussed, it is nothing but the electric fuse. In the beginning of this lesson, we have studied about the electric fuse, which is protecting the electrical appliances by stopping the flow of unduly current, that is during overloading, by breaking the circuit, isn't it? And we know that it is placed in series with the device, and it is nothing but a piece of wire which is made up of an alloy with a suitable melting point. Tell me whether it has got high melting point or low melting point. The fuse will have high melting point or low melting point? High melting point. Okay. High or low? If high melting point means what will happen? If more amount of current is flowing, what will happen? It will not melt away, isn't it? It should have a low melting point, so that when high current flows through that, it will get melt. So it depends upon the circuit actually. The fuse is also chosen depending upon how much current we are going to use. The fuse also will have rating. If you are using a 5 amps current or 15 amps current, or depending upon how much current we are using, accordingly we will choose the fuse. Okay. For example, this aluminum, copper, iron, lead, etc. They are all the metals which we are using for fuse, different fuses. If a current is larger than the specified value flows through the circuit, the temperature of the circuit will be keep on increasing, so that this wire will get fusing. Usually you would have seen that in the meter box and all in our house also. If you take, if you take the fuse carrier, there inside that there is a small wire kept inside. It need not be fuse. Fuse is nothing but a special device made of with a glass vessel. You know that the fuse will be looking like that. Inside the circuit board, if you see, the fuse will be having two, like a capsule, glass capsule, a wire will be going inside. Usually the fuse will be like this, right? But in the house and all, domestic purpose, the fuse carrier will be there. In the fuse carrier, we will be using only a wire only, a small piece of wire. That wire can be the usual wire which are using in your home, but it should be very thin, so that when unduly current flows through that, this wire will get heated up and get cut, so that the circuit will be broken. Okay, so the use or selection of this fuse wire is depending upon how much current is going to flow through the circuit. Yeah, what do you say? I don't know whether you are talking to me or discussing somebody else. Okay. So as I have already told you, the fuse which is used for domestic purpose will have different rating, like 1 amps, 2 amps, 3 amps, 5 amps, 10 amps, even 15 amps. So depending upon how much current is going to flow through that, we'll choose appropriate fuse wire, right? Suppose an electric iron which is consuming 1 kilowatt energy. We are using an electric iron, okay, which is consuming 1 kilowatt power, right? So, and it is operated domestic potential, you know that 220 volts. Now by using this we can calculate current. How much is that? 1000 by 220. It is nothing but something 4.54 amps. So since the current 4.54 amps is flowing through that, we will have to use which one we have to choose? We have to choose 5 amps current. And this 5 amps fuse cannot be utilized for your CPU. Inside the CPU there is a fuse. We cannot use the same 5 amps fuse inside. Or if it is say for example television, we cannot use this 1 amp fuse, because more current will flow, so that the fuse will get cut. So depending upon how much current is flowing through that, we will have to use the fuse. Now the last one is the electric power, isn't it? So shall we continue that, or we will see in the next class? The remaining parts, only the small part of that. Shall we complete it? Tell me. Yeah. So we know that electric power is nothing but the rate at which the electric energy is consumed. This definition you have to remember. Okay, the proper definition is the rate at which the electric energy is consumed in an electric circuit is called the electric power. In the beginning of this session we have seen that power is nothing but given by P is equal to V into I. These three formulae you have to remember. When you are solving numerical problems, based on the data given, you can use either of these three. P is equal to Vi or I square or V square. Yeah. See here, P is equal to Vi. In place of V, we will put V is equal to IR. So that is I into R into I. So that it becomes I square R. And similarly, in place of I, we can put it as V into I is equal to V by R, isn't it? So V square by R. So it is V square by R. So all these three formulae are very, very important. So remember, P is equal to Vi, I square R, V square R. If you remember this, you can change accordingly. Doesn't matter. So all these three formulae are very important, which represent the power consumed in an electric circuit. Formula for power. Now we know that already you just we have learned it. The electric power, unit of electric power is watt. The question, when the sir asks what is the unit of electric power, again you can ask the question, what is the unit of electric power? They will keep on asking the same question, both of us, because you are saying the answer saying that what is the unit of electric power, but the sir is asking what is the unit of electric power. Pronunciation is same, but the answer is different, isn't it? Question is different, answer is different. You can keep on asking like that. So what is that? It is a power consumed by a device that carries, that is the unit. When you say unit, how will you say that the power is 1 watt? In that P is equal to Vi, okay, P is equal to Vi. When will you say P is 1 watt? When Vi becomes 1 and I becomes 1. That means we say that it is the power consumed by an electric device is 1 watt. Yeah, when it carries 1 amp of current and when operated at a potential difference of 1 volt. Okay, thereby we can write the formula and just to put when V is 1 and I is 1, we say W is 1. Okay, so thereby by using that formula you can define that easily. Okay, and we know that for usually the watt is the smaller unit. When it comes to practical purpose, in a domestic purpose, we say we use only kilowatt. It's nothing but 1000 watts. And since the electric energy is the product of power and time, we say the watt hour, kilowatt hour. Kilo is 1000, watt hour, since it is utilized for 1 hour. Okay, so if 1 watt hour is the energy consumed when 1 watt of power is used for 1 hour. When 1 watt of power is used for 1 hour, we say 1 watt hour. If it is 1000 watts is used for 1 hour, we say it is 1 kilowatt hour. 1 kilowatt hour. That is what we say it is the practical unit, that is nothing but 1 unit. 1 kilowatt hour is called 1 unit. Okay, remember that in the domestic purpose, in the EB board we are paying for 1 unit, isn't it? So that 1 unit is nothing but 1000 watts we are consuming in 1 hour. Okay, that is like 100 watts bulbs, for example. If 100 watts bulb is glowing for 10 hours, 100 watts bulb is glowing for 10 hours, then we say the power is 1 unit. Okay, or 10 100 watts bulbs, if it is glowing for 1 hour, then we say the power is 1 unit. That way we have to calculate the unit, commercial unit. We call it as kilowatt hour, kWh, usually called a unit. So how to calculate, as you gave the answer, 3.6 10 power 6 joule is the unit in terms of joule. So either you can say 1 kilowatt hour, or we can say 1 unit, or we can say in terms of joule 3.6 10 power 6 joule. What? Yeah, 1 watt second is nothing but if 1 watt of power is consumed in 1 second, that is called 1 joule. You understand? When 1 watt of power is utilized in 1 second, then that is called 1 joule. Okay? The definition for joule again, it is in terms of energy, heat energy. This power, 1 watt power is utilized in 1 second, then we name it as 1 joule. That is a unit, physical unit. You understand? This 1000 watts is nothing but 1000 watt here the second. Okay, so this number, totally this number is as it is, and if you take this as 1, then 1 watt 1 second is nothing but 1 joule. If 1 watt of power is consumed in 1 second, then it is called 1 joule. Okay, because in terms, sometimes they may ask you to convert this in terms of joules. If they are given the power 1 kilowatt hour, convert this into equivalent joule. Then what you have to do? You have to substitute the value. 1 kilo means 1000. So hour means 3600. So 1000 watts into 3600 seconds, nothing but 3.6 10 power 6 joule. So for conversion purpose, it is useful. Okay. So finally, the problem is there. Some 3 or 4 problems only. Just we'll have a quick look at it. Okay, just an electric bulb is connected to 220 volt generator. Current is given. What is the power? We know what is the formula. P is equal to VI. So simply substitute the value V and I so that the power is 110 watts. Simplest equation. Similarly, next an electric refrigerator rated 400 watts is operated 8 hours per day. This is where this kind of questions will be asked generally. They will give you what is the rating, power rating of the appliance, what is the duration of usage, and what is the cost per unit they will give, and totally we have to calculate. So what is the power? 400 watts. Usage on the per day it is 8 hours, and duration is for 30 days. So we have to calculate how much it is going to cost us for 30 days. Okay, so let us see how to calculate. Very simple only. So total energy consumed, how to calculate? 400 watts is the power, 8 hours per day, totally 30 days. So multiply everything, that's all. Totally multiply that, whatever the value you are getting, it is nothing but watt hour. This you have to divide this by 1000, so it will become kilowatt hour. So this kilowatt hour is nothing but 1 unit. So 96,000 by 1000 is 96. So you are getting 96 units. And they have mentioned it for 1 unit, it is 3 rupees. That is 96 kilowatt into 3 rupees per kilowatt. Simply multiply. So you will get 228 rupees. All multiplication. Straight away by looking at that we can say 408 into 30 divided by 1000 into 3. That's all. Value will get. All everything multiply, divide by 1000 into how much per unit. That will give you the cost for operating the device. Okay. And the next question is very simple only. What determines the rate at which the energy is delivered by a current? Okay. That is in an electrical circuit. Okay. how the rate of energy, how it is delivered by a current, how can it determine that? It is nothing but they are giving their definition, electric power. Okay, when the current is flowing through that, which is determining how much energy is supplied. It is only based on the device, whether it is 100 watts bulb or 50 watts bulb, depending upon the power of the device only, we can see or we can determine the rate at which the energy is delivered. Next, an electric motor takes 5 amps current from a 220 volt line. They are asking you to calculate the power of the motor and the energy consumed in 2 hours. Power and the energy you have to calculate, right? So we know that what is given, voltage is given, current is given, duration of the power consumption is given, 2 hours. So what you have to first calculate, power you can easily calculate, P is equal to V into I, 220 into 5, which is nothing but 1100. 1100 watts, 1100 watts. And similarly, what is the energy consumed in 2 hours? Whatever the power you have calculated into 2 hours, 2 into 60 into 60. That will give you the value 792,000 joules or 7.92 into 10 power 6 joules. In case if they add one more question, express the answer in terms of unit. What will you do? You have to divide this by 3.6 10 power 6. So what is the unit here? 2.2 unit. So if the motor is used for 2 hours, how much energy we have to pay? For 2.2 units you have to pay. Okay, this way calculate the power, multiply by time and divide by this 1 unit, 1 kilowatt hour. So you will get the unit. Any doubt in this? Have you understood this? Say yes or no, don't nod your head. Okay. That's all. So for this, we have seen all the questions, answers, everything. If you got any other questions, we will see in the next class. Okay? Right? Shall we take up next lesson in the next class or after terminal exam? Tell me, when is your terminal exam scheduled? When is your exam? First exam starts on? Fifteenth. Okay. Okay, you tell me later when do you want the next class, so that we will start the new lesson in the next class. Okay, you will have to tell me before that, right? We will meet in the next class. Thank you.